Imagine a world where woolly mammoths once again roam the vast frozen expanses of the Arctic tundra. Picture these majestic giants with their long, curved tusks and shaggy coats, moving in herds across snowy plains just as they did thousands of years ago. It sounds like something out of a fantastical storybook, a vision from a time long past. But what if this dream could become reality? For years, the idea of resurrecting the woolly mammoth seemed like pure science fiction, a wild hope reserved for movies and imagination. But today, thanks to rapid advances in genetic engineering and biotechnology, scientists are closer than ever to making this extraordinary vision real. In high-tech labs around the world, researchers are working tirelessly, pushing the boundaries of what we thought was possible. Their mission is nothing short of revolutionary: to bring back an icon of the Ice Age, a creature that vanished from the Earth thousands of years ago. The woolly mammoth, once a symbol of survival in harsh climates, could walk the Earth again, thanks to the dedication and ingenuity of modern science. But as with all great scientific quests, the path forward is rarely straightforward. Science is full of unexpected twists and turns, and progress often comes from surprising places. Sometimes the answers we seek are found not in the grand, but in the small and unexpected. On the journey to resurrecting mammoths, researchers stumbled upon a surprising breakthrough by creating what they call woolly mice. These are not just ordinary lab mice, but tiny creatures engineered with key mammoth genes, giving them traits never before seen in their species. Yes, you heard that right. Tiny lab mice, now sporting genes from the mighty mammoth. These mice are living proof that ancient DNA can be woven into the fabric of modern life, and that the secrets of the past can be unlocked in the most unexpected ways. This wasn't just a quirky detour or a scientific curiosity, it was a crucial proof of concept. By successfully transferring mammoth genes into mice, scientists demonstrated that it's possible to take genetic traits from an extinct animal and express them in a living organism. These remarkable mice show us that we can transfer extinct animal genes into living creatures and actually see real physical changes, like thicker fur or altered metabolism. It's a small step for a mouse, but a giant leap for the science of de-extinction. This achievement marks a turning point. It's a small step, but a giant leap for de-extinction science, opening the door to possibilities that once seemed unimaginable. The story of the woolly mouse is about more than just mice or mammoths. It's about learning to read and rewrite the very language of life, DNA. By editing genetic code, scientists are unlocking the secrets of evolution and exploring the boundaries of what life can be. These experiments are a test run for a much bigger goal: bringing mammoth traits back to life, perhaps even in living elephants. Imagine elephants with thick fur, layers of fat, and the ability to thrive in cold environments. Traits borrowed from their ancient relatives. So let's dive into this adventure together, where big dreams and tiny mice collide at the cutting edge of genetics. The journey from mouse to mammoth is filled with challenges, surprises, and moments of awe. We'll explore how these small, unassuming creatures are paving the way for a mammoth comeback, serving as living test subjects for the techniques that could one day revive lost species. And we'll ask the big questions. What does it really mean to bring a species back from extinction? What are the ethical, ecological, and scientific implications of de-extinction? Let's find out together as we embark on this incredible journey into the past, present, and future of life on Earth. Before we dive into the fascinating stories of mice and mammoths, let's take a moment to break down what de-extinction actually means, and why it's capturing the imagination of scientists and the public alike. De-extinction is the process of using cutting-edge genetic engineering and biotechnology to bring back species that have disappeared from our planet, sometimes for thousands of years. It's a blend of science fiction and reality, where the boundaries of what's possible are being pushed every day. Unlike the idea of simply reviving a frozen animal, de-extinction is about painstakingly piecing together fragments of ancient DNA, and then editing those genetic instructions into the DNA of living relatives. It's a bit like assembling a puzzle where many pieces are missing, and you have to recreate the missing parts using clues from what's left. DNA, often called the instruction manual for life, holds the secrets to what makes each species unique. For extinct animals like the woolly mammoth, scientists have been able to recover fragments of this genetic code from remains preserved for millennia in the icy Siberian permafrost. These frozen remains are like time capsules, offering a glimpse into a lost world. In the lab, researchers carefully extract and sequence these ancient DNA fragments, using powerful machines to read and analyze the genetic information. The goal is to reconstruct as much of the extinct animal's genome as possible, filling in the gaps with educated guesses based on related species. But ancient DNA is rarely complete. That's why the leading approach to de-extinction focuses on editing the DNA of a close living relative. In the case of the mammoth, that's the Asian elephant. These elephants share a common ancestor with mammoths, making them the perfect starting point for genetic editing. Using advanced gene editing tools like CRISPR, scientists can swap out specific elephant genes for mammoth versions one by one. This process creates a hybrid animal with traits that resemble the extinct species: thicker fur, layers of fat, and adaptations for surviving in cold environments. The result isn't a perfect clone of a mammoth, but rather a new, proxy species, an elephant-mammoth mix designed to thrive in the harsh, icy landscapes where mammoths once roamed. It's a living experiment in blending the past with the present. This approach represents a radical shift in conservation thinking. Instead of only protecting the species we still have, de-extinction asks, can we restore what we've lost? Could we one day see herds of mammoth-like creatures helping to restore ancient ecosystems and fight climate change? Of course, it's a bold and controversial idea. Scientists, ethicists, and the public are debating the risks, the benefits, and the moral questions. But the work is already underway, and breakthroughs are happening right now in labs around the world. The woolly mouse, a genetically engineered mouse with traits borrowed from ancient species, is the first real test of these revolutionary ideas. It's a small but significant step toward the possibility of de-extinction. So, can we really bring back the past, one gene at a time? The answer is still unfolding as each experiment brings us closer to understanding the limits and the potential of this technology. That's the question at the very heart of de-extinction, a question that challenges our ideas about nature, technology, and the future of life on Earth. Why focus on the woolly mammoth? We have well-preserved DNA and a close living relative, the Asian elephant. But the goal isn't just scientific curiosity. Scientists believe mammoths could help restore the Arctic tundra, reviving ancient grasslands and protecting permafrost. Their heavy footsteps and grazing could slow climate change by keeping carbon locked in the ground. This isn't about building a zoo attraction, it's about ecological restoration on a massive scale. The Mammoth Project is driven by the hope of healing the planet, not just resurrecting a lost giant. That's why the world is watching. The key to this genetic revolution is CRISPR, a tool that acts like molecular scissors for DNA. Scientists use CRISPR to precisely cut and swap genes, turning elephant DNA into something more mammoth-like. They start by comparing mammoth and elephant genomes, identifying genes for shaggy hair, fat insulation, and cold-resistant blood. Using induced pluripotent stem cells, they reprogram elephant cells to accept these mammoth genes. CRISPR then edits the DNA, one gene at a time, transforming the genetic code. It's a painstaking process, but it allows for targeted, powerful changes. The result: living cells with mammoth traits, ready for the next step. This technology is the backbone of de-extinction. Without CRISPR, the dream of resurrecting mammoths would remain just that, a dream. But now, it's within reach. When you think about bringing back the woolly mammoth, it might seem logical to start with mammoth-elephant embryos right away. After all, why not go straight to the source and try to create a mammoth-like animal from the very beginning? But there are some big challenges. Elephants, the closest living relatives to mammoths, are endangered. Their populations are shrinking, and every individual is precious. Not only that, but elephants are expensive to care for, require large spaces, and have long pregnancies, almost 2 years for a single calf. This makes experimentation slow, costly, and ethically complicated. Scientists needed a faster, safer, and more practical way to test their genetic edits before moving on to elephants. They needed a model that could give them quick answers and minimize risk. Enter the laboratory mouse. Mice are small, breed quickly, and their genetics are extremely well understood. They've been used in research for over a century, making them the perfect test subjects for early experiments. With mice, researchers can introduce mammoth genes and observe the effects in just a few months, rather than waiting years. This rapid feedback is crucial for refining genetic techniques and understanding how mammoth traits might work in a living animal. The goal isn't to create a mouse-mammoth hybrid, but to see if mammoth genes, like those for thick fur or cold resistance, function as expected in a living system. For example, would inserting mammoth hair genes actually make a mouse's fur thicker? Could cold adaptation genes help mice survive in chilly environments? By testing these traits in mice, scientists can quickly gather data on what works and what doesn't, all in a controlled, ethical, and cost-effective way. In this sense, the mouse becomes a living test tube, a safe, manageable way to de-risk the much larger and more complex mammoth project. It's about breaking a massive scientific challenge into smaller, manageable steps, each one building confidence and knowledge for the next. Think of the woolly mouse as a scale model, a miniature version to test ideas before building the real thing. This approach gives scientists the crucial data and confidence they need to move forward. The humble mouse may be small, but its role in the journey to revive the mammoth is absolutely huge. Creating woolly mice was a breakthrough. Scientists at Colossal Biosciences inserted mammoth hair genes into mouse embryos using CRISPR. The result? Mice with noticeably shaggier, denser fur. It wasn't a full mammoth coat, but it proved the genes worked, even in a different species. This was the proof of concept. Extinct animal genes can function in living creatures. The team also tested genes for brown fat, which helps with cold adaptation. Mice with these genes showed better cold tolerance. These experiments turned theory into reality. The woolly mouse became a living library of mammoth genes. It showed that de-extinction is more than a dream, it's a practical possibility. Each mouse is a step closer to a mammoth. The future of de-extinction just got a little furrier. The woolly mouse sparked excitement and concern. Supporters see de-extinction as a way to heal the planet and advance science. They argue we have a moral duty to restore what we've lost, especially if it helps fight climate change. The project also drives innovation in genetics and medicine. But critics warn of high costs and unknown risks. Should we spend millions on mammoths when living species are vanishing? What if reintroducing mammoths disrupts the Arctic ecosystem? The debate is fierce bold hope versus cautious realism. The woolly mouse is just the beginning of a much bigger conversation. The Mammoth Project raises tough ethical questions, especially about animal welfare. Asian elephants, the genetic starting point, are endangered and highly intelligent. Using them as surrogates for mammoth embryos is risky and controversial. Scientists are developing artificial wombs to avoid this, but that brings new ethical dilemmas. What kind of life would a lab-born mammoth have, alone, without a herd? Critics worry about creating lonely, confused animals for the sake of an experiment. Proponents say careful planning can address these issues, but the ethical debate remains. Is it right to create life for an ecological experiment? The answers aren't simple, and the stakes are high. We're at a crossroads: de-extinction or conservation. One path dreams of resurrecting lost giants to heal ecosystems. The other urges us to protect the species and habitats we still have. The woolly mouse proves de-extinction is becoming real. But should we focus on the future or the present? Can the tools of de-extinction help save endangered species today? The story of the mammoth and the mouse is about choices. What kind of world do we want to build? These are questions for all of us, not just scientists. The decisions we make now will shape the planet for generations to come.